Hello, everyone. Welcome to the Apache TinkerPop's home here on Twitch. I'm Yang. So today we have another TinkerPop Wide stream where we hear from the wider TinkerPop community on their experience with the TinkerPop or graphs in their building of the libraries, tools, graph systems, or other applications. So for this session, we have Calvin, we have Dave and Steven from Amazon Neptune, which is the TinkerPop-enabled, fully managed graph database service. So they're here to talk to us about the features of Neptune's newest release. So they'll be covering the new TinkerPop functionalities as it pertains to Neptune, as well as the addition of the slow query log, graph summary API, and more. So we'll be monitoring the chat as well as the Discord events channel for comments or questions during the stream, and of which we will try to address at the end. So without further ado, I will hand it over to the folks from Neptune and drop off here.
Thanks, Jay. All right, so we're really excited to now have TinkerPop 3.6.2 support Neptune now. Yang kind of explained Amazon Neptune's a fully managed, highly available graph database service from AWS. It supports different models like RDF and property graph, along with different query languages like OpenCipher and Gremlin for property graph and Sparkle for RDF data. Today, though, we're focused on all new support for version 1.210 with Gremlin, as well as some extra enhancements to help you introspecting your graph and finding slow queries in your workloads. So with that, I think I'll turn it over to Dave to have a look at some of those features.
Thanks, Steven. Hi, everyone. Yeah, so today what I'm here to kind of talk to you about is actually not specific to Neptune, because these are actually just features that were added as part of the 3.6 line of TinkerPop. So this works with any of the 3.6 enabled databases. But what I kind of wanted to highlight was specifically going to talk about a couple of the new steps that were added that, as a developer, really make me excited because it makes my life easier. Less code, more readable code, those sorts of things that we always want. And the specific steps we're going to talk to you about today are the addition of the ability to put a map into the property step to save all of those values at once, and to be able to and then the new and the ones I've been advocating for years, the merge V and merge E functionality to really help simplify the overall development process. So let's kind of jump right in and get started here. So really what I'm kind of showing here is probably what as TinkerPop developers, we're all very familiar with this pattern. Sitting here where we have, you're doing it, you basically have a node or an edge that you want to add, and then you want to add a bunch of properties to it. This is kind of the way we've been doing it for years. You come in here, you add the vertex, and then you have a unique step for adding each of the properties. We've all written this. A lot of times this is done by a code where you maybe loop through something like a map in Java or map in Python in order to generate those traversals kind of on the fly and as you go. But they really what it kind of when we really we took a step back and we started looking at how could we make Gremlin easier for developers to be successful with these sorts of kind of paper cuts, these sorts of things where you just have to do a lot of extra work with something we kind of look to focus on. So what we added here was one of the new features in TinkerPop 3.6 was this ability to basically, as opposed to having to individually pass in those items, be able to pass it in as a map. So if you can see here, I'm going to be adding essentially the same as we just did above, where I'm going to be adding a car. But I have a single property step, and from that property step, I'm able to pass in a map. As you can see, this is going to come, and it will basically create the same thing. Under the covers, it's doing the exact same functionality. It's basically unrolling that map into a set of property steps that it adds those individually to it. And in fact, if you go look at how the bytecode gets sent across, that's actually what you'll see it's doing. But really, this was kind of a way to simplify the amount of code that we have to write and maintain as developers in order to do that. And something like this example I gave here is not necessarily the most complex to be able to write from a user's perspective or a developer's perspective. But if you take something like this, so what this is doing is this is actually taking in it's using the side effect step to inject maps. So this is a common pattern we see when we're working with customers, where you have a map of data, a map of properties that you want to be able to put into your put in and associate with a vertex, but you don't necessarily know exactly what all of those properties are ahead of time in order to be able to kind of write code to do that. So what this is the long running existing way to actually be able to dynamically make those properties basically loop through the injected map of values and be able to print it out. I don't know that. I have to thank Stephen here because I took this example from him because I know from one of his blog posts, because I don't know that I could have written this myself. It's certainly not easy to maintain that. So with this news property step, basically that entire 10 lines, 15 lines of Gremlin, whatever that is, basically gets put down into 2 steps. So with this new property map functionality, really kind of focused on making that very, very easy for customers. And that sort of flows into the next kind of step I wanted to talk a little bit about here is the merge V step. So I'm sure we're all well familiar with the upsert pattern that we have in TinkerPop and have had for years, this fold, coalesce, unfold type of pattern. I don't know about you, but certainly when I started developing and when I work with customers, being able to understand how to efficiently write these sorts of queries definitely takes a bit of mental gymnastics in order to figure out how this actually works and why it actually works. With TinkerPop 3.6, we kind of yet again took a little bit of a step back, looked at what customers were really trying to achieve, and decided that we were going to look at making a bit of a more declarative style step as opposed to the very imperative style of the fold coalesce. And what we did is we came up with 2 steps. We'll talk about both of them here, those being merge E and merge V. And really the entire idea behind these steps is that you can sort of give the step essentially what the state you would like the thing that you would like your graph to end up looking like, and it will do the work behind the scenes in order to actually achieve that. So you can basically achieve this by by doing a few things. First off, you can this exact same fold coalesce pattern here is what we can achieve using this single essentially 1-step methodology there, where you basically pass in a map to merge V. What merge V does is it uses all of those values that you pass in. It looks to see if those already if a vertex that matches those values exist. If it does, it returns that vertex. If it doesn't do that, it'll actually create that vertex. So what you see here is, I'm able to come in here, pretty quickly turn, this fold coalesce pattern into a singular step, and then in this example, I have element map and unfold, so we can make it easy to read. But trust me when I say you only really need that first step in order to make that happen. And you can do this with a variety of things. You can do this with labels. You can do this with properties. You're also able to do this with an ID. So this is a very useful scenario if you actually have known IDs. If you're working with a database that allows you to set the IDs like Neptune does, being able to use this and merge on a specific ID is very, very helpful in a lot of application development scenarios. One other interesting thing I think you can do here is you can combine these together. So you can combine both merge V with the property map step to really simplify the very common task of find me a vertex and then set all of these, find or create me a vertex, upsert this vertex and then create me all these properties. So as opposed to having to combine together, 30 different lines of Gremlin in order to do that, we now are back down to, 2 steps. Makes it much easier to maintain and much easier to read. And for users, developers that are new to the Gremlin language, it makes it much more approachable to be able to understand how to achieve what you're looking to achieve there. But when we kind of went out to people, we went out to users of TinkerPop. One of the things that definitely came back was, well, that's very nice. Sometimes I want to be able to just merge on stuff, but sometimes I want to actually be able to do different things based on whether I'm creating something or I'm merging something. And this is something we saw often with the fold coalesce pattern, is that ability to come in and actually, very, common use case. I want to set a created date or a modified date on a specific on a specific property. So if I run this here, you'll see that it came through. It actually created that vertex, and it set the created date property to 1/1/2023. If I run the same one again, now that this vertex exists, it will actually basically perform the modification, the update aspect of that. And you can see how that kind of gets called out here as modified date. To achieve this functionality, you basically are using that merge step that we talked about, but you use that in conjunction with options. And options basically allow you to specify on create or on match type options. And you can do that. And with those specific things, you can then use that to create more, to add additional properties or different types of properties for something that was created versus modified, something like that. And the other kind of common pattern that we saw is very common, especially when you have an application that you want to be able to, create large amounts of data, maybe coming from something like a Kafka stream or some other type of streaming thing, is to be able to inject these groups of maps into a value or into a query to really simplify what you have to be able to do in order to make that what you have to do in order to be able to save that information into your graph. You do that. This actually works very well with the merge step. Basically, in this case, the merge, we're injecting an array of maps, we're unfolding them, and then we're just merging them. So this, as you can kind of see, is actually a very simplified way to look at this data. One other interesting thing, specifically from a Neptune perspective, is these merge V steps and these merge E steps are fully optimized inside Gremlin. So as we get to some of these more complex use cases, these injection use cases, these on match, on creates, you're going to get the optimal performance with Neptune using these merge steps versus some of the limited optimization we can do with the fold coalesce pattern. So I think that's a really key piece for any Neptune users out there to think about. So we talked about merge V to be able to basically upsert vertices, but the other really common use case people want is to be able to upsert edges. And to be honest, upserting edges inside the fold coalesce pattern is complex, to put it nicely. If we look at it here, basically what these 15 lines of Gremlin or whatever are doing is really coming in and basically connecting two vertices together. But it has to make sure that both of those vertices exist, and then that edge does, or then upsert that edge if it exists. And this is sort of a fold coalesce wrapped inside a fold coalesce wrapped inside of a fold coalesce. So it's a very coming in afterwards to maintain this, figure out what you were trying to do 6 months ago, coming back and trying to make it work is definitely complex. With these new merge V and merge E step support, we're able to take this entire block of Gremlin and express it as these three simple lines. The first line is I'm basically creating the vertex for Audi. The second one is I'm creating the vertex for VW. And then the third one is I'm going to create an owns edge between those. I'm either going to create or return an owns edge between those if it already exists. So it's definitely from a usability developer experience, I think this is a huge step forward. Like I said, I've been really wanting this step for, I don't know, Steven, I've been bugging you for this step for years at this point. So I'm really,
it has to be, we got to be pushing back at least almost 5 years, I would say.
Yeah. So needless to say, I'm really excited to see what we can do here. Something else to note on this, that the ability to kind of specify different things on create and on match are not limited to merge V. They're also limited to merge E, or they're also available in merge E, excuse me. So that was kind of everything I kind of wanted to highlight here. 3.6 does come with some other steps that we didn't discuss here. The element step to get back to the parent element from a property map, the fail step, things like that. But I just really wanted to highlight these specific ones because I think, at least from my perspective, the property map, the property that accepts a map, and the merge E and merge V are really huge leaps forward as far as the developer simplifying the developer experience for Neptune. So that was kind of what I had. Unless there were anything that Kelvin or Steven wanted to kind of throw in here as well, if not, I can kind of kick it over to Kelvin.
Yeah, I think you did a good job with that, Dave, which is why I dragged you on here to talk about it. Thank you.
Like I said, it's been 5 years at this point wanting this. So.
There you go.
Yeah, I think in general, it's worth even calling out that I think all of us here are TinkerPop committers and Gremlin enthusiasts, as well as, we contribute, to Neptune as our day job. So this 3.6 release, I think for TinkerPop's probably one of the biggest, Stephen, we've done probably since 3.4. I think there's so much great functionality in this release, and seeing Neptune now picking it up, hopefully we'll see other providers picking it up, and yeah, the number of times we've all had to help people write those fold coalesce patterns that you just showed, Dave, versus this nice declarative pattern. I think it's just great. And I think in general, we'd all agree what we're trying to do with Gremlin is just make it easier to use. So filling these kind of gaps with new steps where appropriate, just to make it easier. So, let us know in the chat what you think, if you've played with these steps, if there's other things you'd like to see. And I'm going to go through a few more things specific to Gremlin, then show you a couple of things a bit more specific to Neptune, just to help Gremlin developers debug their Gremlin queries a bit. So, but first, just a very brief segue. Everything we're showing you here is being run in the context of Jupyter notebooks. Many of you probably recognize that these are Jupyter notebooks. What you may not know is this is not unique and only available in the Amazon Neptune context. We built these as open source notebooks. They support a variety of Gremlin, OpenCipher, and RDF Sparkle supporting backends. So even if today you're not using Neptune, you're just wanting to hear what we're saying about Gremlin and TinkerPop, you can still use these notebooks that we're showing you with like a Gremlin server and run your own experiments. And you can see there it's github.com AWS Graph Notebook is where the repo is. And we're always looking for pull requests if you're so inclined as well. So that's just what we're using for all these demos. Nothing proprietary to Neptune here. Just happens that we've added a few magic commands to the notebooks to make Neptune and other graphs easier to work with. So I was going to start, Stephen, with just one more of the steps that we added. We did this one a while back too, but it's now in Neptune in the latest release, which is, I know Janus Graph and Titan back in the day had a regex step, but we've never had one in the Gremlin language itself. It's always been like a provider added extra thing. So one thing we've added in TinkerPop 3.6, it's now also in Neptune, since Neptune's moved up to that level, is the regex step. So with these notebooks, by the way, you can load sample data. Mine's already loaded, but I'm just using, imagine that, the AirRoots data set from my demo today. But let's say you wanted to run a little regex query where you want, what have I got here? Descriptions of places that start with DAL and then are followed by any other number of characters. You could today do that with like starting with. So maybe this isn't the best example, but here's a really simple example of using the regex step to do that. And we found right away that there's several that meet that criteria. And just about anything that you could put into sort of the regex101.com website, Java regular expressions is going to work here with the regex syntax we have. So we can start to get a bit more ambitious with our regular expressions and even start to sort of you go into some of the more interesting regex selectors, and they all work pretty well. And you can notice I put a time on the cell. They all work fairly well. There are, always with regex, there's some amount of overhead looking things up. So keep that in mind. Maybe don't try and run a regex over 100 billion nodes. Maybe try and filter them first before you apply the regex. But overall, this is pretty straightforward. Just a nice new predicate in the has step in the where you can use when you're trying to do pattern matching with Gremlin and now in Neptune. And we'll just show one more here where it's just a little bit more complicated regex. And we're finding anything that's got a word followed by an O, followed by an apostrophe, followed by more characters. And again, it works just as you'd expect it to work. So that's TextP regex. It's nice that I think we've got that in the Gremlin language now, as well as not needing it to be a database specific optimization or addition to the language.
I'll just say it's been as we talk about what these changes have kind of meant. It's been interesting to go back through to try to undo all of the old answers to questions on Stack Overflow that say, oh, well, we don't have regex, so you must do it in this really complicated way. There have been going through those Stack Overflow posts. There's definitely been a lot of things very much simplified by 3.6.
Yeah, I think we've got a lot of book chapters, documentation, Stack Overflow posts. We've got to go back and change them all for fold coalesce, for regex, for all these things. I think we've been trying, right, Stephen? But I'm sure we've missed some. So
yeah, I've spent several hours, I'd say, updating old questions and things to try to, and they're not just old questions that nobody's referencing. There many of them are very much like highly upvoted sorts of questions that you get those little badges for in Stack Overflow. So they are things that Google is going to put up front in their search results when people are looking for those things.
I remember way back when I showed you a really early draft of Practical Gremlin when it was still evolving, and I had a little section on building your own regex primitive. You were like, "Oh, cool, that's fun," and we can throw that away now. So,
that's right.
So let's talk a little bit Neptune-specific things, but we're going to focus on Neptune-specific things that are applicable to Gremlin and TinkerPop. So one of the things that could have been easier, I think it's fair to say, in Neptune that we've now addressed is kind of the question, what's in my graph? You know, we could write a Gremlin query and we could sort of say, give me all the labels and go group count them. And so we can, you know, I don't have too much loaded here. I just have a couple of graphs loaded. I have the Eroots graph and also a large number of English words that I've been using to play around with the regex stuff some more. But then you'd have to go do the same thing for your edges. You might want to say, what are all the distinct labels? What are all the distinct property keys? Just how many nodes have I got? And you can do that with queries when the graph is modest in size, I mean, maybe even in the millions. But once you start to get up to some of the graphs that Neptune supports, which are in the billions of nodes and edges, doing it with queries is just problematic because Neptune does exact counts. If you ask Neptune g.b.count, it will go count what's in the graph right this minute. But under the covers, one of the things that Neptune does is maintain statistics that are used by the query optimizer to help it decide the reordering of queries, the best way to go look things up in the index that Neptune maintains. But we've never really exposed that benefit to an end user. We've provided simple APIs in the past to let you regenerate the statistics, but we've never really built on that until now to say, well, can I actually see what you're holding that those statistics have generated? So we've introduced in Neptune what we're calling the summary API. And it's a REST API. You don't actually access it through Gremlin. It's actually done through a REST API. And in the simplest case, you just curl your notebook with a curl command. Sorry, I said notebook, your Neptune host with a curl command. And you can either ask for the short form or the long form results. And you'll get back most of the things you've always wished you could get and had to try and get with queries and was not always easy to get with queries. So we've got the node count, we've got the edge count, we've got the number of node labels, number of edge labels, all of the distinct node labels, so that those are the set in the graph, same for edges. And then for each of the properties, how many times those properties occur. So you can start to get a sense for, well, I've got a lot of things with a value property, I've got quite a few things with a type property. And then likewise on the edges, there's only one edge property in this graph, which is the distance on the Eroots graph, and you can see that number there. And then there's some additional counts as well. And you can enable the full details mode and get even more back than this. What we've done with the notebooks is add a couple of magics, so you don't have to use the curl commands for this. There's % statistics that you can use to check the timestamp when the statistics were last generated, or actually force them to be regenerated. What Neptune does is when you load a large amount of data, it will update the statistics. If more than about 10% of the graph data changes, it will do it right away. If your graph hasn't seen much activity for a number of days, Neptune will redo it. But it may be that you've just done some amount of work and you want the absolute latest, and so you can manually at any time re-trigger this computation as well. So if we just go over here and we add a new node to our graph, we don't have any dogs right now. I think we've got airports and words. So we're going to add a dog to our graph, and Baxter's now in the graph. And just to prove that, we can run our group count query again, and we can see we now do have a dog down here. Because we didn't change much of the graph, Neptune's not going to go recompute the stats right away because we don't want to constantly be stealing CPU cycles computing the statistics. We only want to do that either when we're told to or when we know it just makes sense. A lot of data has changed. So I'm going to do a refresh on my property graph statistics. I won't worry about the RDF ones for this example. And if we now come down, having done the recompute, I'll skip down to the summary here using the magic this time. And we can see that we now have a dog in here. And if you were counting the nodes before, you'll have noticed the node count's gone up by 1. And what did that dog have in terms of a property? I think it had a name. So we now have a name down here for the dog. And if we were to go delete the dog, we could recompute the stats. We'd see it goes away again, or over time, Neptune will just keep updating the statistics. So I think anybody building an application that needs to ask questions like, what is in my graph? It could be a visualization application or something that needs a faceted search of the graph, something like that. This API will help with those kind of applications. You can now very easily just go get a JSON document back that's got everything that we're able to tell you about the graph in a single place. And then you can go use that with your application.
I was going to say the one other thing that I've heard a lot of customers ask for is if they want this sort of feature and functionality, if they do a large bulk load or large import of data, that they want to be able to, know that I put in 1 million nodes and 1 million nodes were saved, those sorts of.
Right. And it's worth saying, these are what I would call approximate counts, that if the graph is consistently mutating, they will always reflect the last time the statistics were generated. If the graph isn't mutating, then they will be an absolute right this minute count. Given the highly concurrent nature of Neptune, that sort of is a good compromise where if you don't have any writes going on, it will be absolutely the latest, but if you do, it will be as recent as you calculated the stats. Another thing we've run into a lot, and with Neptune, but with many different graph implementations I've been involved with, there's a class of application where maybe millions of queries are being fired at the database, but maybe those queries aren't even all sort of static in nature. Maybe they're machine generated. And it's often very hard to answer the question, which queries were slow, or why was the query slow? Now, with Neptune, as with Gremlin, there are profile and explain features which will, if you know which query is slow, allow you to drill deeper into why that is. But it's often the case you're firing so many queries at your database that you don't actually always know why that CPU at midnight last night spiked to 75% for 5 minutes. What was going on then? So what we've added to Neptune in the latest release is what we're calling the slow query log. And with the slow query log, you can establish a threshold for how often you want it to jump in. So you can say if any query is more than 5 seconds, I want it logged, and that's the default. And in fact, if we run the status command here, that will give you the status of the current Neptune cluster. And you can see I've got my slow query log in debug mode. We currently have 3 modes, which is basically info mode, debug mode, or disabled. Debug just gives you extra information about what kind of index was used, how it was used. For a lot of cases, info will be all you need because it will just give you back details about the actual query, so you can go profile it additionally if you need to. And you can see down here, we've currently got the timeout on my cluster set to 3 seconds. The default is 5, so you can play with that number to decide what a slow query is in your case. Is it 3 seconds? Is it 100 milliseconds? You have a lot of flexibility there over what you want logged. When the query is logged in the slow query log, it gets copied to Amazon CloudWatch, and then you can access CloudWatch to see the query log. I'm going to show you a couple of ways you can do that. You can do it from the CloudWatch web console, or you can just write a query that gets it back, in this case from our notebook, and we can see what's been going on. So I've got a Gremlin query here that's a little bit nasty. It looks for routes from Austin to the Agra airport in India. It's nasty because there's only very limited ways to actually make the last hop to get into Agra. So Gremlin has to do a lot of work here to find this. This query generally will take 5 to 10 seconds. It might take a little longer here because my instance may be cold in the background. I'm using a serverless instance and I'm letting it scale down when I'm not using it. But you can see now the query ran and we have a % time on the cell. So we can see this particular instance, it took about 9, almost 10 seconds. So that's definitely above our 3-second bar we call this a slow query in my setup here. So now we can go look at the logs. These two cells I'm going to skip. They just tell you what the names of the logs are. I've got that hard-coded for this particular demo. So what we're going to do first of all is get the log events from CloudWatch. This is if you're not familiar with this is the AWS command line interface, which is similar to the SDK that you could do this from Python or from Java, but I'm just doing it from Bash in this particular case. And I'm going to say, give me the last thing in the log. So events -1 is the last thing. Well, there it is. You could probably just see our query in here if we look carefully, not too easy to read. So with a bit of bash hackery and a bit of JQ, we can make that pretty. And we can now see that, okay, lots of information here. So we received a WebSocket query. It had a 200 response, so it was okay. We can see the plain text for our query here. So there's our query looking for Agra. We can also see, though, what we call the fingerprint, which is sort of the anonymized query. So if you're in an environment where you want to look at it, but you don't want to show them the actual query, you can just show them the fingerprint version of the query. And then we've got lots of information here about when the query started running, what the overall runtime was. We also have the serialization time for the query. And then lots of information I'm not going to go too deeply into right now, and some of this is like the debug level, but it will actually show you which of the indices that Neptune maintains internally were used to actually run that query. So you can see that we did a lot of looking up of various things in indexes as that big query fanned out, looking for all those possible routes. One other thing I've done in this notebook is just create a bit of Python code further down. I won't bore you with the Python code, but it takes this result using the SDK and just builds a little HTML viewer, and you can tell it how many results you want back. And so you can imagine in a environment where you're only interested in which queries were slow, we can see here the timestamp when the query was run, the start time, the time it took, and then there's our query string. This is something I think we'll probably add to the notebooks as a proper magic. So you could do like % slow query log or something, but that just gives you kind of a sense of what this can do. And lastly, I mentioned that all the things you run also get captured in CloudWatch if you've got the slow query log turned on that way. And so we can go over to the CloudWatch. I think I ran this one earlier. I didn't bother to refresh here, but you can see the same thing there. This is what we call the web console for CloudWatch, if you're not familiar with that. And there again is that same query essentially sitting there. I ran it earlier, you can see, but it's essentially the same query. And hopefully this will help a lot when you have those Gremlin queries that you're just not sure which one caused that CPU spike you see in your metrics. Maybe, like I said, you're sending millions of queries an hour, and you're just trying to find the slow ones. This gives you that start on your detection trail to figure out which query that was. And you could then go additionally profile the query to see, why is this query taking so long? What happened here? What did it touch that made it so expensive? So Stephen, that's what I had. Another new Gremlin feature and a couple of new nice Neptune features for hopefully making the Gremlin programmer's life easier.
All right, thanks, Kelvin. That was good. The slow query log is definitely a big one for me. I think it is going to help a lot in identifying problems way more easily than traditionally sort of used to with Neptune. So that's going to be really nice. It actually kind of plays in a little bit to what I just wanted to talk about briefly with the improvements to Gremlin driver, which happened in both 3.5.5. I know we're talking a little bit about 3.6.2 today, but 3.5.5 and 3.6.2 have these changes. I'm also covering a little ground that was covered by our TinkerPop's newest committer, Ken, who talked about this in the last contributor cast. And so if you're interested in this, you might want to hear his kind of take on it as well. But for this, specifically, we want to see 3.6.2 usage with 1.2.1.0 for Neptune. But if you are on older versions, you can use 3.5.5 for those cases. We worked on really looked at three areas for improvement with the driver. And again, this is specifically the Java driver that we're talking about here. But we focused on the stability around host connectivity, more robust logging, and greater clarity solutions to failure scenarios. With that, we'll go into kind of look at each one of these, starting with the stability part around host connectivity. This is just a basic, what everybody kind of does with the driver. If you're at all familiar with it, you create a cluster in a client, and then you send lots of requests. Here I'm just sending 10,000 G.Vs to the server, and you do something with the results, right? And that's it. And that's great until it doesn't work, right? Until there is a moment of network instability, until there is some kind of other problem that might happen along the way, like perhaps you have a mixed workload and you have lots of little small queries, but then there's a few big ones that may take a little more time, and things start backing up enough that it takes just long enough for the driver to be unable to borrow a connection from the connection pool, and then you have a problem, and you get an exception. And what that exception tends to look like is something like this. Tends to be what a typical log is going to end up looking like. It's not terribly pretty, and it doesn't tell you. It didn't tell you a whole lot, right? You get your timeout exception that I was talking about. You typically time out waiting for a connection from the connection pool to become available, and that would immediately mark that host as being unavailable because it couldn't find its way there. So clearly there must be some problem there. And then that means all of the following requests that you had all queued up, if you're doing thousands of requests every second or whatever it is, you're going to end up with lots of no host available exceptions firing, and that fills the logs. And you can see that the no host available exception is kind of generic in that it just says, hey, well, check the error logs to find the actual error, the original cause. And finding that original cause can be kind of tricky to dig up that original timed out exception if you're sending a lot, if you have a very heavy workload going on. And so even if you find the timeout exception, it kind of just tells you that, hey, well, maybe things were unavailable, right? It's possibly unavailable. We weren't really sure. So you don't have a lot to really go on in debugging this problem in earlier versions. So to address that, did several things with stability. We tried to improve the criteria for determining host availability. That was like one of the first big steps. What data could we use from the driver itself to determine whether or not that host was really there, or we just had a momentary lapse in the network, or something else, right? So looking at the connection pool and looking at how other connections behaved helped determine that. If all the other connections, if you got 64, a connection pool with 64 connections in it, and 63 of them are working really well, but the 64th wasn't, there's a pretty good chance that things are still okay. So using little hints like that to tell us whether or not the host was available kind of definitely changed the dynamics of how host availability was determined. We prevented connection pool from closing too early. That was another important improvement. The connection pool is pretty expensive to tear up and tear down, so like avoiding that at all costs is pretty important to maintaining a nice stable performance. And so that improvement was really helpful. And we also changed connection retries to be far more immediate. There's a setting, I can't remember what it's called, but it controls how long there's a wait before connection retries on a dead host. That still exists, but we're retrying more immediately. There's no wait from the first time that there's a failure, for example. When there's new requests made, we make an attempt to try to reconnect. So there's lots of attempts to try to reconnect if there's an actual disconnection from the host, and it brings things back in order much better. So there's definitely some behavioral differences that occur as a result of this. You definitely have a reduced exception rate using 355 and 362. You should not see floods of no host available exceptions when you have those heavy workloads. So your logs should be a lot cleaner, and should mostly contain, if you do have exceptions at all, it's going to around connection pool type issues, and connection issues, it's mostly going to be around timeout exceptions. There'll be some failure to borrow that connection from the pool, and that's the thing that you would focus on debugging. Okay, and so how that looks sort of like this now. As we look at 3.5.4, we already kind of looked at what those logs look like. They look sort of similar in 3.5.5, but you can see there's a couple of important differences. One is there's an actual potential cause that's included. So there are a few patterns that we've noticed over the years of things that go wrong when there's a timeout. And we've documented a bunch of those in the TinkerPop reference documentation for the driver in the troubleshooting section. But those causes are also sort of encoded into the exceptions themselves, so that you're given some guidance as to what might be going wrong with that situation. And more often than not, it has something to do with how long you're waiting for a connection in relation to the workload that you're executing. Okay, so changing that, how long you're willing to wait, can help. Increasing the size of the connection pool itself can help. And all of that guidance is kind of, like I say, built either into the exceptions or looking into the troubleshooting section for the reference documentation. The other thing to note is that the logs have been improved here in the sense of we grab sort of a snapshot of the connection pool at the moment of the exception, and that can yield some additional information as to how busy the connections are in that connection pool. If a bunch of them are sitting in the recycle bin waiting to be recycled for some reason. So these things might yield some more information to us as you go and look through your error logs and running into these sorts of cases. So I think, getting onto these new versions will be very helpful for anyone on, say, 3.5 and 3.6. And they should help tremendously getting more reliability into your applications. And I think that's about all I had to say about the drivers. Let's bring Yang back, and we can talk about questions.
Yep. Thank you,
Steve,
Calvin.
Stephen, while you're doing that, I was going to say one thing. What you just showed isn't unique to Neptune either, right? Any Gremlin server user could benefit from this.
Yeah, by all means, for sure. This is definitely a kind of a TinkerPop general issue, and it will help with whatever your favorite graph database is.
Yeah. Yes, definitely. Thank you, Dave, Stephen, and Calvin. Very exciting to hear that these new features are available with the new release. So that should make querying and debugging much easier for users. And I think we have time for questions right now. Any questions?
Yeah, this one was actually posted in the chat. It was handled in the chat, but I thought for purposes of the video, it would be worth kind of answering here.
Sure. So we have Daniel C. Weber asking, we're using an OpenSearch cluster with Neptune to facilitate case-insensitive searches for infixes. Is this new regex feature powerful enough to get rid of OpenSearch? I think
I think the answer is probably not, unless you have the ability to pre-filter, as I mentioned. So if you're going to have to search this over, say, millions of documents, I think OpenSearch is still going to be your go-to for that kind of scale. But if you're able to sort of pre-filter, like you've got 20,000 cities in a graph, then I think it would work pretty well. The queries using the feature do get fully optimized into the Neptune internal execution format in the Neptune case, but the Neptune indices are more built around exact matches. So we're still, to some extent, having to match across those indices. In my testing, it worked pretty well, but I think there is going to be a point where the OpenSearch integration is still going to be much more powerful if you're doing this a lot. If if it's your initial filter and you want to start with 1 million or 10 million, then OpenSearch, I think, will do a better job. If you can pre-filter, say, it has to be a city in Texas or something like that, then do the regex. I think it's going to work really, really well for those.
Cool, thank you. We have another question from
regex is popular.
Yeah. So, quick question about the new regex updates. Does the new stuff support the full capability of the regex spec, I'm assuming, such as back references and lookaheads?
As far as Gremlin's concerned, I think, Stephen, our native TinkerPop uses the Java regex, right? So whatever anyone does with just straight out of the box TinkerPop, TinkerGraph, Gremlin server, it's going to be whatever the Java pattern matching classes allow. This is also going to vary, I think, for each implementation as to what they document as their regex. I think you'll find right now that ours looks a lot like the Java one as well. So I think that supports lookaheads and back references, but I'd honestly have to check to make sure. But you're talking about the kind of question mark brackets type of reference things. I think that should work in the regexes, but it will always be a little bit implementation specific. I don't think we mandated in the Gremlin spec, did we, Stephen, which regex to use. I think it's an unwinnable conversation, that one.
That's a good way to put it. Let's see.
Okay. Oh, another question. So can the property step also take a traversal as an argument?
Today, it actually cannot take the traversal as an argument, but this has been something that's been highlighted as something that we want to, I think, a feature we want to look at adding, because even when I was writing my examples, there are a lot of scenarios where being able to take a traversal as an argument would have been a very useful thing. So I think this, I would say not today. We'll look to add this in the future.
And I think, Dave, we talked about, making it work nicely with the stream too, right? So today, merge E and merge V, the stream can flow in and they'll work. The property's a little bit more static right now, but we should make that work with the stream as well.
Completely agree.
Cool, thank you. Oh, another regex question. So the regex predicate looks nice, but are there any plans for more string functions in Gremlin? Oh, that would be cool.
Who wants to take that one? Dave, you want to go first?
Sure.
I think this is Dave's other thing he's wished for 5 years.
This is the other thing I've wished for 5 years. Yeah, so for TinkerPop, the 3.7 release that's under development now, we've actually put out, and you can go see this on the futures portion of the documentation, basically a proposal for adding more list, string, and datetime functions. Neptune and many of the other databases and most of the hosted ones really don't allow us to do things like Lambda closures anymore. That really allowed a lot of functionality that TinkerPop relied on for things like two up or two low or joining together strings, those sorts of kind of things that many customers want to do, many users want to do, I want to do, and it's not easy to accomplish today. So we do have a proposal out that we're working on for adding a lot of string functions. So things like two upper, two lower, join, concatenate. I mean, the fact that you can't get like a string length today easily is something that we definitely kind of want to work on, as well as some common list functions and then some common datetime functions.
And I think with our TinkerPop committer hats on, taking off our Neptune hats completely, we want to make Gremlin as a language really easy to use. So having things like string functions, list functions in Gremlin is definitely something I think we're all keen to do. And just to make sure it's absolutely clear, Dave, what you're describing there, those documents, they're all on the TinkerPop repo, yes. Right? There's nothing proprietary there. So we invite people to join the dev list, join the conversation, and give us your feedback.
Yeah, please give any feedback. Like I said, we're working on the implementation, but we can still tweak them.
Definitely. Thank you. A question, excuse me, on the summary API. So how long does it take for statistics to regenerate so that summary API stays up to date? Yeah, that looks very instant during the demo. So
yeah, maybe I didn't quite answer it. So generally it's quite quick. So like, the graph I was showing you, it's less than a second, it's instant. Even if you're in the sort of millions, tens of millions, it's going to be very fast. If you're into the hundreds of billions, it may take a little bit longer because there's a lot to do to recalculate. We also do have some limits above which we won't try to go. Like if you have a massive graph with just millions of different property key names, we might not try to keep that all up to date. But for the most part, for the average graph that we see, it's going to be quick. And you may or may not even feel you need to regenerate it if you mutate more than 10% of your graph, or if you just haven't done much for a few days, Neptune will just do it for you. Generally, it'll be fairly quick. It's only in those very extreme cases where you have this sort of massive graph with maybe many other complicating factors. It could take, could take a few minutes or whatever to generate. But in general, it should be pretty quick.
And I would also say it sort of depends on what you want to use them for, whether you really need them to be 100% accurate. If you just did a bulk load and you want to know that the exact number of nodes is the exact number of nodes, it makes sense. But if you just want to know, okay, what labels exist in my graph, it's unlikely, once you have any amount of data in your graph, you're not usually adding them all the time. You're not adding them with frequency. And if you are, that's probably a different conversation about good data modeling practices. But it's like I said, it also whether you need them up to date is kind of dependent on your use case there too.
Yeah, very true. Okay. I guess I don't see any more questions in the comments or anything, but yeah, thank you, Calvin, Dave, and Stephen for this presentation. And thank you all for watching this TinkerPop Wide event. So we'll see you guys on the next one if there's no further ado. All right.
Thank you.
Thanks, everyone.
Thank you, everyone.
Thanks, everyone.